Hi. In this video, we are going to start a new course for JEE Advanced, and depending on students' choices, like you guys have told me that you wanted to start with conic sections. So we are going to start with coordinate geometry, and we'll start with the conic sections part of coordinate geometry. So the first few videos will be about parabola. So in this course, I will be doing theory as well as problems. So today's class is primarily a theory class where we try to understand the curve that is known as a parabola. In future videos, we'll do problems, previous year's questions on this topic, and basically find out all that there is to know for JEE Advanced for this particular topic, right? Eventually, like what I want to do here is we'll start off with parabola, then move on to the other conic sections, ellipse, hyperbola, and then I will also cover straight lines and circles. So circles will be the fourth topic, and then finally straight lines. And that will finish our course on coordinate geometry. So this is the sequence that I plan. Every particular chapter, every chapter like parabola will have several theory plus problem solving videos. Theory plus problem solving videos. So what you will have here is a complete discussion of the topic. If you go through these videos and do the problems here, you should not have any problems in facing JEE advanced problems. So let's begin, and we'll start off with the basic definition of a conic section. A parabola is a special case of a conic section. So what is a conic section? It's the locus of a point that moves in the plane, that moves in a plane in such a way, that its distance from a fixed point, let's call that fixed point as S, is always proportional or in a constant ratio to its distance from a fixed line. To its distance from a fixed line. And we can call that line as M. So basically what you are saying is if that point is P, this is a movable point. And if we have a fixed point S somewhere here, right? And a fixed line, let's say the line is like this. The parabola is the locus of all points P such that the distance of PS to PM is always fixed. PS by PM, this is the PM, this is the perpendicular distance to this fixed line. This is fixed line. And this is the distance to the fixed point. This fixed point is known as the focus. And this fixed line is known as the directrix. So when I'm defining a general conic, I have to say that no matter where this point P moves, the ratio PS by PM is always constant. So if PS by PM is equal to a constant, then that P defines a conic section. Right now, the curve that I have defined is, you can see that PS by PM here is not the same as PS by PM here. That has happened because I have drawn it by hand and my hand drawing is not accurate. However, if you want to have a conic section, the ratio of PS by PM is equal to some constant. This E is a constant. And if you have this situation happening where P is a movable point, S is a fixed point, and M is a fixed line, then that point P defines a conic section, right? So let's understand it in a little more detail, The point S is known as the focus. Your fixed line M that I called M is known as the directrix, and the constant ratio of PS by PM, which is known as E, is also called the eccentricity. And these facts are true for all conic sections. Now, there are some cases that we will encounter as we go along in the course, we will understand. So, but I will just list down the different cases here. These are cases where E is equal to certain values. If E is equal to 1, the constant ratio is 1, the curve that T describes is a parabola. If E is equal to something between 0 and 1, if the eccentricity is between 0 and 1, P is an ellipse. If E is greater than 1, P is a hyperbola. P is a hyperbola in that case. If E is equal to 0, then P describes a circle. And if E tends to infinity, it can never be equal to infinity, but if it tends to infinity, the conic that P will describe, and P describes a pair of straight lines. As we cover all the other topics, I will get into the details of this. Right now, I just want to list all of this for you so that you are not confused. So basically, all of these curves, right from pair of straight lines, circles, ellipse, hyperbola, and parabola, all are related, and they can be described by a family of second degree equations in X and Y. So they are all related, they are similar to each other in some sense, and they are all following this pattern. PS by PM is equal to E, and you have different values of E defining different types of curves, right? So in general, what will the equation of the conic section look like? So if I try to do this, that PS by PM is equal to E, and E is a constant, and I take some general conditions like, let's assume S to be alpha comma beta be the focus, and the line M to be having equation AX plus BY plus C equals 0. That becomes a directrix, and E is the eccentricity. And let's take Px comma y is a variable point on the conic section, variable point on the locus, right? Then how do I find the equation of the locus P, right? So what we will do is we'll simply try to simplify this. We'll say PS square is equal to E square into PM square. And if I draw the situation like this is my line M, which is basically AX plus BY plus C equals 0. And my S is somewhere here, which is alpha comma beta. And P is somewhere here, X comma Y. Then obviously this is my distance PS, and this is the perpendicular distance PM, right? Now, because PS square is equal to this, we can find out PS square by distance formula. It comes out to be X minus alpha whole square plus Y minus beta whole square is equal to E square. And we can find out this PM square also, which is the perpendicular distance from P to the line. And that would be, by basic theory, how to drop a perpendicular from XY to a line. You have to put this point in the line equation and divide by the sum of the squares of the X and Y coefficients, right? That would be my PM square. This is standard straight lines theory. So if you don't know this, you need to revise the straight line chapter. This is going to come here, A square plus B square, right? Now, This is coming as the required locus a square plus b square times x minus alpha whole square plus y minus beta whole square is equal to e square ax plus by plus c whole square, right? So you can imagine this and realize that this will be a second degree equation in both the variables x and y, right? Notice that you will get x square, y square, x square, y square terms from both sides. You will also get a 2xy term from here. You will get a 2x, 2y terms from both sides, and you will get constant terms, right? So this is how we can eventually write the standard equation of a conic as this expression. I will write it here, the 2-degree equation in x and y. So the general equation of a conic becomes something like this: ax square plus by square plus 2hxy plus 2gx plus 2 capital Fy plus c equals 0. This becomes the general equation of a conic. Now, how am I getting this equation? You can basically collect all the terms of x square and y square here, right? You will get an x square term from this term and you will get an x square term from here. If you bring everything to one side, you will realize that the x square term will be a square plus b square minus a square e square. This will be multiplied with x square. And we can call that as capital A, right? So similarly, if you simplify this whole equation, you will end up getting an equation that looks like this. And that becomes your general conic, right? Eventually, when we do specific cases, like today's class, we are going to discuss specifically a parabola, we will have certain conditions under which this equation becomes a parabola. But right now, we are trying to understand what a general conic is and how we can say that this equation represents a general conic. The reason it represents a general conic is because we are getting it from here. PS by PM is equal to A. From here, we can derive an equation like this, right? It all depends on the choice of your fixed point and the choice of your fixed straight line, and also the value of your constant eccentricity. If all of these things are given, you can automatically derive a general 2-degree equation in x and y as the equation of your conic, right? Okay. So now what we will do is we'll come to understand certain basic terms when we talk about a general conic. So let's write first of all the equation of the conic. So this equation is a conic. Technically, it can be any of 5 different things. It could be a parabola or an ellipse or a hyperbola or a circle or even a pair of straight lines. We have seen earlier the conditions on the eccentricity for each of these things to happen. Eccentricity should be 1, should be 0 to 1, should be greater than 1, should be 0, and should tend to infinity for this case, right? Now, for any general conic, we will define some basic terms first of all, right? The first thing is the principal axis. The principal axis, or sometimes known as the axis of a conic, is the straight line through the focus and perpendicular to the directrix. Now, if you recall, we already know what the focus and the directrix are. Focus is the point S and directrix is the line M. So what we want is a straight line that passes through the focus and is perpendicular to the directrix. That will be your principal axis of a conic. The second term that we want to talk about is the vertex. And sometimes it can be more than one vertex in a conic. So it could be vertices, right? So the vertex or vertices of a conic is the point of intersection of the conic section with the principal axis. So what is the vertex of a conic? The point of intersection of the conic section and the principal axis is known as the vertex of a conic. So if you think about it, if you have a parabola like this, the axis of the parabola is lying like this. This was the focus. The axis intersects the parabola here, and this becomes the vertex. On the other hand, if you have an ellipse looks like this. The principal axis is this line. The principal axis intersects the conic in 2 points, and these are the vertices. These are the two vertices, right? So generally, the vertex or vertices of a conic section is the point of intersection of the conic section with the principal axis. There could be one, there could be more than one points of intersection, right? Okay. So now what is the third term that we want to understand? The term is a chord. So what is a chord? The line segment joining any 2 points on a conic is a chord. We know the meaning of chords from basic circles. In circles also, the line joining any 2 points on a circle is known as a chord. So similarly, we have this term for a conic section. The next term is a focal chord. Focal chord is a chord passing through the focus. Passing through the focus. Okay, so that is an obvious term. The next term that you need to know is called a double ordinate. What is a double ordinate? So you have to pay attention because sometimes these terms can be confusing for students. The question uses a term which you don't understand. So you need to make sure that you know your definition. So this is a chord passing through a point P on the conic and perpendicular to the axis of the conic. Perpendicular to the axis of a conic. That will be known as the double ordinate of point P. Double ordinate of point P. For example, if I have a parabola like this is my axis of the parabola. This is my focus. If there is a point P here on the parabola, the chord through P, but perpendicular to the axis. So it should be a chord like this. This is perpendicular to the axis. This line is the double ordinate of point P. So notice that this double ordinate will cut the parabola at 2 points, P and Q, right? So that is the meaning of double ordinate. So in general, double ordinate can be through any point of the conic, right? And we have one special double ordinate that is known as the latus rectum. So what is the latus rectum? It is the double ordinate of a conic passing through the focus. Double ordinate of a conic that passes through the focus. That double ordinate is known as latus rectum. So for the same situation, this was the focus. This was a random double ordinate. This is a normal double ordinate, which is perpendicular to the axis, right? But if we make the double ordinate the double ordinate should pass through the focus, it will be like a focal chord, right? It will be a situation like this, a chord that passes through the focus and is perpendicular to the axis of the parabola. And this becomes your double ordinate, right? This length is known as the latus rectum. In a parabola, we will soon discover that it is equal to 4a if y square is equal to 4ax is the equation of the standard parabola. So we will find out more properties about the latest rectum as we go along. For now, just remember that it always has to be perpendicular to the axis of the parabola, and it has to be a double ordinate of the conic that passes through the focus of the conic. That is your latest rectum. Okay. The next point that you need to be aware of is known as center of a conic. Center of a conic. So a chord, so the point which bisects every chord of the conic, passing through it is called the center of the conic. The center of the conic. So what is the meaning of this definition? The center of a conic is a special point such that any chord of the conic that passes through the center will always have the center as the midpoint. So for example, if this is my ellipse, the center of the conic is this point O. Because if you have a chord passing through this and this chord is PQ, you can show that O is midpoint of PQ. And any other chord also, if it was RS, basically all the chords passing through O are bisected at O. O is also midpoint of RS. In the standard situation, curves like ellipse, hyperbola, and circle all will have centers. These three conic sections have centers because the center is the point like this, or the center of the circle, or the origin in a standard hyperbola. However, curves like parabola and obviously pair of straight lines won't have any centers. There is no point on a parabola such that there is no center for a parabola and pair of straight lines, because you cannot find a particular point in a parabola where every chord passing through it is being bisected there. So conics which have a center are known as central conics. So which conics are central conics? Ellipse, hyperbola, and circle. And parabola is a non-central conic. It doesn't have a center, right? Okay. So now that we have looked at some basic 6-7 terms related to a general conic, let's also come up with a criteria that helps us identify when a given equation is a conic, right? So let's write the general equation. Let's write the general equation of a conic. And this general equation is the standard 2-degree equation in X and Y. So this is my equation for the standard conic. Now in this, we will calculate a quantity called del, and del is given by this ABC plus 2FGH minus AF square minus BG square minus CH square. This is called the discriminant for the 2-degree curve. Discriminant for the curve. This discriminant has to be remembered, and you also have a determinant form of this, which I will not write down. I prefer to remember it like this. You should remember the value of this discriminant, and because this is super important when you want to decide what kind of conic this is, what kind of conic this curve is, right? So there are multiple cases. There is case 1 when del is equal to 0 and case 2 when del is not equal to 0. If del is equal to 0, we have the case called a degenerate conic. This is known as a degenerate conic. And if del is not equal to 0, it is a non-degenerate conic. Non-degenerate conic. So, what are the special cases in both the situations? So, if del is equal to 0, the curve will be a pair of straight lines, which could be both real and imaginary. So, you have multiple cases here. If del is equal to 0 and h square is equal to AB, the curve is a pair of parallel lines. If the situation is del is equal to 0 and h square is greater than AB, then it is a pair of intersecting lines. Pair of intersecting lines. And if finally the situation is del is equal to 0 and h square is less than AB, then what we have is a pair of imaginary lines which are intersecting at a real point. So basically it is a single point, basically. Intersecting at a real point. So the curve in that case becomes a single point, right? The detailed theory of why this is happening, we will discuss when we discuss pair of straight lines. Right now, I'm starting with parabola, right? So I cannot discuss all of this in detail right away. We'll get to it, the description of how this happens once we do the pair of straight lines chapter, right? We are going to right now focus on del is not equal to 0 case. Here, if you have h is equal to 0 and a is equal to b, the curve is a circle. This is the case where del is not equal to 0. Then, if you have del is not equal to 0 and h square is equal to ab, it is a parabola. If del is not equal to 0 and h square is less than ab, then the curve is an ellipse. And finally, if h square is greater than AB, then the curve is a hyperbola. So these are the four main cases for non-degenerate conics. It can be circle, parabola, ellipse, or hyperbola. And you can decide that first by checking the values of del. Del should not be equal to 0. And in that case, we have four separate cases. H is 0 and A is equal to B, the equation is a circle. H square is equal to AB, it's a parabola. H square is less than AB, it's an ellipse. And H square is greater than AB, it's a hyperbola. But all of it, remember, results from the values of del. You have to first figure out this del for given equation. Only then you can decide what kind of conic section it is, right? Another point that you should know here is how to find the center of a conic. So given this equation, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals 0, how do I find the center of the conic? So the way to find the center is if you call this equation as S, this expression as S, then what you need to do is do the partial derivative of S with respect to X and write this equation. And write a second equation, partial derivative of S with respect to Y equals 0. And you have to solve equations 1 and 2, solve 1 and 2 to find the center. So what does this mean? First of all, how do I find partial derivatives? When I say partial derivative with respect to X, I'm going to assume that Y is a constant for us and our differentiation is only over the S terms. So the derivative here, this partial derivative will become 2ax plus 2hy plus 0 because by square is a constant plus 2g plus 0 plus 0, right? So our equation is becoming ax plus hy plus g is equal to 0. That's the first equation. From this partial derivative, I get 0 plus 2h 2x plus 2by plus 0 plus 2f plus 0 is equal to 0. So from here I get hx plus by plus f is equal to 0. And now I have to solve these two equations to get the center. By simple simultaneous equations, if you solve, you will get the point hf minus bg by ab minus h square, comma, gh minus af by ab minus h square. This will become the coordinates of the center. Notice that you don't have to remember this formula. What you need to do is follow this process. Just do the partial derivatives, get your equations, and therefore from there, what you can do is solve for the center, right? Don't try to memorize everything. Also, you should realize that the center coordinates are coming like this, and notice that this tells us why sometimes we have conics that do not have a center. Because if h square is equal to AB, the center is at infinity, right? The coordinates here, notice the denominator is becoming 0 in both the terms. So the center's coordinate is at infinity. So that happens, h square is equal to AB happens in two cases. One case is when it is a non-degenerate conic, when it is a parabola. So if del is not equal to 0 and h square is equal to AB, the curve was a parabola, and we can see now that the center of a parabola will be at infinity. The other cases would be if del is equal to 0 and h square is equal to AB, and then the curve would be a pair of parallel lines. If del is equal to 0 and h square is equal to AB, it will be a pair of parallel lines. And in that case also the center is at infinity, right? So not always you have a central conic, and that is what we learn from this, right? Okay. Now, what we will do is do a couple of examples which will help you understand what we have learned so far. So this is question 1. The conic equation is given by this. Plus 2x plus 14y minus 2 equals 0. And we have to find out which kind of conic this is, right? So obviously, we know the values of all the coefficients here. So first thing to calculate is del. Del is equal to ABC plus 2FGH minus AF square minus BG square minus CH square, right? So if you calculate the value here, A is 13, B is 37, C is minus 2. Then you have plus 2FGH. So plus 2 times F is 7, G is 1, H is minus 9. And then you have a minus 13, 7 squared, minus 37, 1 square, plus 2, minus 9 square. If you calculate this value, you end up getting del is equal to, you have to calculate this. There is no other way. You are getting a lot of negative values. This becomes minus 962. Then you have a minus 126, minus 637, minus 37, plus 162, right? So plus 162 and minus 962 is minus 800. And this is again minus 674. And this is minus 1, minus 800. So this is minus 1600. Our del is coming as minus 1600. So first of all, del is not equal to 0. So it's a non-degenerate conic. So it can be only circle, LS, parabola, hyperbola, right? Now, how do we decide for all of those cases? Once we know that it's a non-degenerate conic, we have to calculate h square and compare it with AB, right? So h square here is minus 9 square and AB here is 13 into 37. So clearly we have h square is less than AB, and therefore del is not equal to 0 and h square is less than AB. So the situation is an ellipse. So that's how you are supposed to figure out how or what a particular equation is, right? I will look at another example. You have this situation. Find the conic represented by the equation root over ax plus root over by is equal to 1. So right now, this equation is not in our standard form, right? This equation is not in our standard form. So how do we figure it out? First, we'll have to convert it into standard form, and the way to do that would be to square it. So I will do square on both sides. You will get ax plus by plus 2 times root over abxy is equal to 1. And still I have radicals here which I need to remove. So what I can do is 2 times root over abxy is equal to 1 minus ax minus by and square this thing. Right? If I square this thing, I will get a square x square plus b square y square plus 1 minus 2ax minus 2by plus 2abxy is equal to 4abxy, right? So finally, the equation on bringing everything to one side, I'm getting this plus b square y square minus 2abxy minus 2ax minus 2by plus 1 equals 0, right? Now this equation is in the standard 2-degree curve form. And now the first thing to do is to find out the value of del. So del will be equal to ABC, and A is A square, B is B square, C is 1, ABC plus 2FGH, 2 times F. F is the coordinate of Y, so it is actually minus B. G is for X, so minus A. And H is here, it's minus AB, right? Okay. And we have ABC plus 2FGH minus AF square. So minus A square. What is F square? It is B square. And then you have minus BG square. So B square, G is A, so A square. Minus CH square. C is 1. And H square is again A square, B square. So you're getting del is equal to A square, B square. This becomes a minus 2a square b square, and there is a minus 3a square b square. So del is coming out to be minus 4a square b square. So clearly del is less than 0, right? If del is less than 0, basically that means it is not equal to 0, and this is the case for a non-degenerate conic, right? And now let's check the value of h square and ab and compare them. H square was equal to a square b square, and AB was equal to also a square b square. Both are equal. So you have h square is equal to AB, and this is a non-degenerate conic with h square is equal to AB, which is a parabola. So this is the kind of thing that you need to be comfortable doing. You need to know all the cases and basically be able to apply them and find out the type of curve that you have, right? So I hope you have understood what we have discussed so far. Now we come to the basic meaning of a parabola, right? We will start our study of parabola in detail now, and that is PS by PM is equal to E, where E is equal to 1. If the eccentricity of the conic section was 1, it was called a parabola, right? So in general, we should have PS is equal to PM. Here, P defines the locus of a parabola. Locus of a parabola, right? Now, how do I get the equation here? So the first equation would be the simplest equation of a parabola or the standard equation of a parabola. We can get more or different types of equations for a parabola also, but we start out with trying to find the simplest equation of a parabola. How do I make it simplest? I have to choose my S and line M carefully. And if I choose them to be really easy points, then my equation will become quite easy, right? So what I will do is we will choose our S to be the point A comma 0. We'll choose the S to be the point A comma 0 and the line M to be the line X is equal to minus A, right? If you choose this situation, then what is PS? PS is the distance of P is the point X comma Y. So what is PS? PS would be X minus A whole square plus Y square, that is PS, is equal to PM. PM is the distance of this point to this line, right? So if you think about it, the line equation is X plus A is equal to 0. And you have to find the distance of this point to this line. So that will be simply X plus A by root over 1 square, right? This is the distance. So when you square it, you will get X minus A whole square plus Y square is equal to X plus A whole square. And when you simplify this, you will get Y square is equal to 4AX. So y square is equal to 4ax is the parabola equation only under some special conditions. What are the conditions? The focus was chosen to be the point a comma 0 and the directrix line M was chosen to be the line x is equal to minus a, right? So the graph of the thing looks like this. You have focus here at a comma 0. This is S and the directrix is the line here x is equal to minus a. This is my directrix. And the parabola basically will be this curve. This is my parabola. P can be any point on the curve, right? The axis is this line. The axis becomes the line y is equal to 0. And this point is known as the vertex. This vertex in this case is 0, comma 0. The equation of the parabola is y square is equal to 4ax, right? And here, basically, the principal axis has been defined, the directrix has been defined, vertex has been defined, focus has been defined, right? And you can also find the equation of the latus rectum. Latus rectum will be a double ordinate passing through the focus. So you will see this line perpendicular to the axis will be the equation of the latus rectum. So that would be at x is equal to a. And you can see that x is equal to a, it will intersect the curve at, if you put x is equal to a in this, you will get y square is equal to 4a square. So this point will be a comma 2a and the corresponding point here would be a comma minus 2a. So the length of the latus rectum is basically this length and that length is equal to 4a, right? So these are some basic properties that we can figure out for the standard parabola, right? Notice also that the parabola, the standard parabola is symmetric about the x-axis, about its principal axis. What do I mean by it is symmetric about its principal axis? What we mean is that if x comma y lies on the parabola, on the curve, then its reflection, there will also be a point which is the reflection, which will be the point x comma minus y. X comma minus y also lies on the curve. So if there is a point on one side of the principal axis, if you reflect the point on the other side, you will get another point on the parabola, right? So that means it is symmetric. Also, notice that the parabola has a single vertex. If you recall from our initial discussion, what was the vertex? the vertex was the point where the axis meets the curve. There is only one such point here, and that is the origin here, 0, 0, right? Obviously, there is no component of the parabola on the negative side, this side. There is no portion of the parabola on this side of the x-axis and y-axis. Because if x is negative, in this equation, y will not be real, right? If x is negative, the quantity on the RHS of 4ax becomes negative, and then y square will not be real, right? So that is a basic understanding of the standard parabola. We have also found the length of the latest rectum. We have found that equal to 4a. We can also discuss a certain important property. So if you have a standard parabola, y square is equal to 4ax, and this is a point P, x comma y. This is my focus, a comma 0. This is my directrix, line M, which is x is equal to minus a. So we can deduce one thing. What is the focal distance of a point P? The curve equation is y square is equal to 4ax on the parabola. What do I mean by focal distance? The distance of this point P from the focus. That is focal distance. Notice that this is equal to PS. We need the distance PS, right? But according to the definition of the parabola, it should be equal to the perpendicular PM, because parabola satisfies PS is equal to PM, right? So this PS should be equal to this distance PM, right? And now think about it, since the vertex was 0, 0 here, you already know this much is x, and we already know this gap here was a. So the focal distance is clearly x plus a, right? So on a standard parabola, the focal distance is x plus a, right? Also, another thing to recall here is, or understand here, is this line is basically the tangent at the vertex of the parabola. Tangent at the vertex, and that the equation of the tangent at the vertex is x is equal to 0, right? So this will become useful later on. Tangent at the vertex is the line tangent to the curve passing through the vertex, and that is x is equal to 0 in our standard parabola. What we will do next is basically start looking at different versions of our basic parabola. Right now we have looked at y square is equal to 4ax. In the next section of the course, what we'll look at is different types of parabolas. So what I want to look at is parabolas like y square is equal to minus 4ax, x square is equal to 4ay, x square is equal to minus 4ay, and even an oblique parabola. Before that, I will also see what is a parabola that has been translated a little bit, a shifted parabola. You can also write it like this, x minus h whole square is 4a y minus k. And finally, also look at an oblique parabola. So that will have an equation something like this. Something like this. So we will try to understand all of these different types of curves. And basically the point in all of this is not to try to remember it, but the point is to try to understand it well enough that if a problem comes with a different twist, where the curve is slightly different, you should not be confused. You should always be able to draw the parabola correctly and not be confused by the different types of equations you might encounter. So the next video on this course will cover all the different forms of the parabola equation. And then after that, we'll go to the main concepts of tangents and normals and many other things that we need to cover in the theory for here. So hopefully you have learned something from this video. Please pay attention to the series. If you go through the series carefully, make notes and do the problems that I will be discussing, your coordinate geometry and conic sections especially will be pretty strong, and you'll be able to solve whatever questions comes in the exam. So pay attention to the following videos. I'll be doing it over the next few weeks. I'll be finishing this course. And if you like the content, please subscribe to the channel, share it with your friends, and support the channel. Uh, I'll see you next time. That's all for today.